Hey, Ivan from the EV Stock Channel here, and in this episode of the battery raw material supply chain, we're going to be covering all things graphite. Starting off with the basics, what graphite is, the difference between natural and synthetic, where are the major deposits, who are the major producers, and how much of the market is controlled by China. We're also going to be looking at what supply and demand looks like, how supply chains can be localized, and will silicon and solid state replace graphite? A lot to cover, so let's get started. But before we begin, thank you to all the Patreons for your support, and remember, all content is my opinion only and not financial advice. And also, this episode is brought to you by Tesla Taxi, allowing you to rent a number of different models like the S, 3 or X throughout Australia. Promo code will be below in the description. First of all, what is graphite? Well, graphite is a rock, or to be more precise, a crystal or crystalline form of carbon with its atoms arranged in hexagonal structures that are stacked in many layers. There are also two types of graphite. There's a natural graphite, which forms naturally, and while there are various subtypes, the main one is flake graphite, and different sized flakes of graphite are used for different applications. For anode applications, flake graphite is processed into a round spherical shape by mechanical attrition processes. Synthetic graphite is more expensive to produce, but does have better cycle life. As for performance, like-for-like comparisons have been hard to come by, so we'll have to do more research in that area. Synthetic graphite anodes are made from needle coke, which is a byproduct of the fossil fuel industry and needs to be heated to thousands of degrees, which generates a CO2 footprint of 5,000 tons per ton of material produced. So Western producers of synthetic graphite that can reduce their CO2 output and use clean energy would be preferred over Chinese producers that still use fossil fuels. And one company that is working on this is Novonix, with their production plant in Chattanooga, Tennessee, and they have Jeff Dawn as their chief scientific advisor. Moving on to the main uses of graphite. The main uses for graphite are refractories, which are materials that are resistant to extreme heat, pressure, or chemical decomposition. And an example of this would be the heat shield tiles that were used on the space shuttle. Other uses for graphite are lubricants, metallurgy, and of course, pencils. That's right, lead pencils are not made from lead, but instead graphite. And of course, there's batteries, a segment that is expected to grow and an area we're going to be focusing on. So when it comes to batteries, graphite predominantly makes up the anode part of the battery. According to Benchmark Minerals, about 10% of the value of the battery is the anode, and by weight, a vehicle with a 75 kWh battery pack would contain around 90 kilos or 200 pounds of graphite. And when we look at the top three battery materials side by side, and in this case, an 811 battery cell, we can see how the costs compare as per Benchmark Minerals. Graphite makes up 9.4% of the total cost, while lithium makes up 12% and nickel 24.7%. So these three elements amount to about 46% or almost half the cost of the battery. And yes, this number varies with different cell chemistries. But as we can see with the following slide, while cathode chemistries often vary, anodes are primarily graphite. And yes, I will address silicon and solid state later on. So in summary, these are the three key battery raw materials that need to be controlled if you want to have consistent supply and control over your battery costs. Because as manufacturing improvements push the price of batteries down, more and more of the battery costs by percentage become the battery raw materials. And with carbon taxes expected to increase over time, sourcing battery raw materials that are mined in an environmentally friendly way with low CO2 footprints will likely be key in my opinion. Moving on, Turkey, China and Brazil have the world's largest reserves of graphite, and there is a drop-off to the next three countries which are all located in Africa: Madagascar, Mozambique and Tanzania. When we look at global production, China is by far and away the leader. According to the US Geological Survey, the country accounted for 62% of world graphite mining in 2020, led by their top producer BTR Energy Materials, which produced 65,000 tons last year, although the rest of the world is catching up for two reasons. One, China is streamlining production, which involves taking some of their highest polluting producers offline, and both the US and the European Union have declared graphite a supply critical mineral with the focus to develop local supply as opposed to relying on Chinese graphite. So is that even possible? Well, in North America, there is only one operational graphite mine that is currently operated by a French company called Immerse in Quebec. However, that mine is nearly depleted and will soon cease operations. But Nouveau Monde Graphite is developing a major resource in Quebec, and according to their 2018 feasibility study, they plan to produce an annual rate of 100,000 tons of graphite. Not to mention, Nouveau Monde is vertically integrated, meaning they will not only mine graphite, but also produce 45,000 tons of anode material. To put that number into perspective, according to Benchmark Minerals, that would be enough to feed 1.5 30 gigawatt-hour battery factories. The other thing that caught my eye with Nouveau Monde is that they plan on producing graphite in a carbon-neutral way using hydropower to generate electricity, and their mining equipment is electric. So I hope that more companies can follow this lead, as it will silence a lot of EV critics that claim fossil fuels are cleaner due to the emission and pollution produced by the mining of battery raw materials. Meanwhile, in Europe, Talga Resources are developing a major project in Sweden, which aims to also produce 100,000 tons of graphite concentrate, and like Nouveau Monde, this project will be run on renewable energy and produce anode material. Next up, let's look at supply and demand for graphite, and according to Benchmark Minerals, in 2023 they expect there to be a shortage of graphite. In North America, this is the time when we anticipate there to be a lot of production of EVs, such as the Cybertruck, the Tesla Semi, the Rivian, the Ford Hummer, and these are all large battery pack vehicles that will require a lot of graphite and a lot of battery raw materials. The same thing can be said of Europe, with many of the European auto OEMs planning on massively increasing EV production like BMW, Daimler, and VW for example. And finally, what about silicon or solid-state batteries? Will they reduce the need for graphite? Well, it appears that as you add more silicon into a graphite anode, the energy density increases, so silicon doping is actually beneficial for graphite. And I have even seen reports that anodes with 15 to 20% silicon doping are rivaling the performance of what solid-state batteries should be able to do. And on that topic, even if there are major breakthroughs in solid-state technology, it would still take many years for production to ramp up. And it's not as if the whole industry would just switch overnight from graphite anodes to solid-state. So in my opinion, that will take many years. However, this is an area that I'll be watching with interest. So in summary and in my opinion, with EV and battery storage demand increasing, there will only be an increase in the demand for graphite. Europe and North America will push to localize their supply chains with the emphasis on low emissions along with reducing their dependency on China. Silicon doping will continue to increase and improve the lithium-ion battery cell, while solid-state